Hi all. Today let us discover how statistics helps us understand data and make better decisions. Let's move on to the measures of central tendency part 2. Today we will explore median, quartiles and mode and see how these measures helps us to understand data in a simple and a meaningful way. Let's begin with median. When we have a set of data, we may want to know which value lies exactly in the middle. The value that divides the ordered data into two equal parts is called the median. Median is also called as the positional average because its value is determined by the position of the observation in an ordered data set. So, unlike the arithmetic mean, we do not need to use every value in the calculation. We simply locate the middle position. In simple words, the median is the middle value of the data set when the observations are arranged in ascending or descending order. Now let us see how to find the median for a raw data. First, we arrange the observations in ascending order. Then we check whether the number of observations is odd or even. If n is odd, the median is the observation at the n plus 1 by 2th observation. For example, if we consider the raw data 3, 5, 7, 9 and 11, here the number of observations is equal to 5 is an odd number. Then the median is given by 5 plus 1 divided by 2, that is the third position, 7. If n is even, the median is the average of the n by 2th observation plus n by 2 plus 1th observation. For example, if we consider the data 1, 2, 3, 4, 5, 7, 9 and 11, here the number of observations is equal to 8, which is an even number. Then median is given by 8 by 2, that is 4th observation, plus 4 plus 1, 5th observation. So 4th plus 5th observation divided by 2, value here is 4 plus 5 divided by 2 is equal to 4.5. Now let us see how to find the median for a discrete frequency distribution. Here the data is given along with its corresponding frequencies. So instead of looking at individual observations, we use the cumulative frequency. First, we find the total frequency, capital letter N, by adding all the frequencies. Next, we calculate N by 2. Then we look at the cumulative frequency column and find the first cumulative frequency that is just greater than the fraction N by 2. The corresponding value of X gives us the median. Now let us calculate the median of a discrete frequency data in the following example. Now, the solution follows the following steps. We will enter the given values of xi's in the first column. Then we enter the given fi's in the second column and we obtain the sum of the frequencies. And in the step 3, we will calculate the cumulative frequency column. Now the step 4 will be we will calculate the cumulative frequency just greater than n by 2. Here the total frequency is 120. So 120 divided by 2 is equal to 60. So the cumulative frequency just greater than 60 in the cumulative frequency column will be 65. So the corresponding x value is x is the median. Now let us understand the formula for calculating the median for the continuous frequency distribution. We have to start with identifying the median class. First we calculate the total frequency n, then we find the fraction n by 2. Next we look into the cumulative frequency column and identify the median class. The median class is the class whose cumulative frequency is just greater than the fraction n by 2. After identifying the median class, we use the median formula. We start with the lower boundary of the median class, then the total frequency, then the cumulative frequency before or preceding the median class, and the frequency of the median class and the class width. So here the median formula is given by L plus H by F into N by 2 minus C. The quantity fraction n by 2 minus c tells us how many observations we still need to reach the middle observation after the previous classes. We divide this by the frequency of the median class to find the required proportion of the median class. Finally, we multiply with h, the class width, to convert this proportion into a distance within the class, and then we add it to the lower boundary of the median class. Let us now take an example to understand how to find the median for a continuous frequency distribution. Here the data is given in the form of the class intervals along with their corresponding frequencies. The class intervals are 0 to 10, 10 to 20, 20 to 30 and so on. The corresponding frequencies 12, 18, 27, 20, 17 and 6. Now the solution procedure follows as we will enter the class intervals in the first column, and then we enter the FIs in the second column and we find the sum of the frequencies, and in the next column we will find the cumulative frequency. Then we will find the cumulative frequency value just greater than the n by 2 from the cumulative frequency column to identify the median class. After identifying the median class, we will find the corresponding frequencies and the cumulative frequency preceding the median class, and we use the formula median is equal to L plus H by F into N by 2 minus C. In the solution, now in the first column, let us write a class interval, and in the second column the corresponding frequencies, and the third column the corresponding cumulative frequencies. The cumulative frequencies are calculated like the first one will be as such the frequency value 12, then this 12 will be added with 18 to get 30, then 30 plus 27 will provide us 57, and 57 plus 20 will provide us 77, plus 17 it provides 94 plus 600. So the total frequency is equal to 100. So adding all the frequencies as we are getting n is equal to 100. Now to locate the middle observation, we calculate n by 2. Therefore, our median class will be 20 to 30 as the cumulative frequency just greater than 50 in the cumulative frequency column is 57. Now let us write the values of L. L is equal to 20, which is the lower boundary of the median class. Then C is the cumulative frequency just preceding the median class. So it will be above, or the first cumulative frequency just above that 57 is 30. Then the corresponding frequency of the median class is 27, and here the class with the h is equal to 10 as the class interval spreads from 0 to 10, 10 to 20, etc. Now we substitute all these values in the formula L plus H by F into N by 2 minus C. We will get the median value as 27.407. Now let us understand the concept of quartiles. Quartiles divide an ordered data set into 4 equal parts with each part containing 25% of the observation. The first quartile Q1 is called the lower quartile. It represents the point below which 25% of the observation lie. The second quartile Q2 is the median. It divides the data into 2 equal parts, so 50% of the observation lie below it and 50% lie above it. The third quartile Q3 is called the upper quartile. It represents the point below which 75% of the observation lie. So we remember like Q1 is 25%, Q2 is nothing else, the median is 50%, and Q3 is 75%. In this way, Q1, Q2 and Q3 divide the data into 4 equal parts of 25% each. Now let us see how to find the first and the third quartiles Q1 and Q3 for a discrete frequency distribution. Just as we find the median using the cumulative frequency, we can also find Q1 and Q3 using the cumulative frequency column. First, we calculate the total frequency, capital letter N, and then we find the fraction N by 4. From the cumulative frequency column, we find the cumulative frequency just greater than N by 4 and the corresponding X value is Q1. So Q1 is the value of the X just greater than N by 4 in the cumulative frequency column. Similarly, for finding the third quartile, we find the cumulative frequency value just greater than 3n by 4 and the corresponding X value is the Q3. Now we will see an example to calculate the Q1 and Q3 for a discrete frequency distribution. Now let us work out the same example step by step. First we enter the given values in the xi in the first column and next the fi in the second column and the cumulative frequency in the third column. Now we find the total frequency n. Here n is equal to 124 and now we calculate n by 4 which is equal to 31. Now we see in the cumulative frequency column a value of 31 just greater than will be 45 and hence the corresponding Q1 X value will be the Q1. That is here Q1 is equal to 4. Likewise, we find the cumulative frequency just greater than 93. It is 94 and the corresponding X value is 6. So the third quartile value will be 6. Now let us calculate the Q1 and Q3 value for continuous frequency distribution. For a continuous class interval type, we have to first of all find the Q1 and Q3 class by finding the n by 4 and 3n by 4. Then we use the formula Q1 is equal to L plus H by F into n by 4 minus C and Q3 is equal to L plus H by F into 3n by 4 minus C. Now let us see an example. We will enter the class intervals in the first column, corresponding frequencies in the second column and the cumulative frequency in the third column and the total number of frequencies given by 100. Now n by 4 is given by 25 and 3n by 4 is given by 75. So the cumulative frequency just greater than 25 in the cumulative frequency column is 30 and the corresponding class interval will be the Q1 class. So that is going to be 10 to 20. Similarly, for finding the Q3 class, the value just greater than 75 in the cumulative frequency column will be 77 and the corresponding class 30 to 40 is called as a Q3 class. Now we'll find first of all the Q1. For Q1, the lower boundary will be 10 and the n by 4 is given by 25 and C is the cumulative frequency just preceding the quartile Q1 class and F is the frequency of the quartile class and H is equal to 10. Substituting all these values in the formula, we will get our Q1 is equal to 17.2. Similarly, for finding the Q3, the L, the lower boundary of the Q3 class is 30 and 3n by 4 is 75 and the cumulative frequency preceding the third quartile class will be 57 and the corresponding frequency of the third quartile is 20 and the class with this given by 10. Substituting all these things in Q3 formula, we will be getting Q3 is equal to 39. Now let us move on to the another important measure of tensor tendency. While the median tells us about the middle position of the data, the mode tells us which value occurs most frequently. So in simple words, The mode is the value that occurs more frequently. So raw data, we simply look at the observation and count how many times each value occurs. For example, 2, 4, 5, 4, 7, 4, 9. In this data, we can very clearly see that the number 4 appears 3 times. So therefore, mode is equal to 4. For a discrete frequency distribution, the number of times each value occurs is already given as its frequency. So we simply look at the frequency column and identify the highest frequency. Then the corresponding x value is the mode. For example, in this, the maximum frequency is 25, and hence the corresponding x value is equal to 6 is the mode. For a continuous frequency distribution, we cannot simply take the values with the highest frequency because the data is given in class intervals. So first we identify the modal class. The modal class is the class interval having the highest frequency. Once we identify the modal class, we use the following formula. Mode is equal to L plus H into F1 minus F0 divided by 2F1 minus F0 minus F2. Here, L is the lower boundary of the modal class, F0 is the frequency of the class preceding the modal class, F1 is the frequency of the modal class, F2 is the frequency of the class succeeding the modal class, and H is the class width of the class interval. Now let us calculate the mode for the following frequency distribution. So this is a continuous frequency distribution type. Here we will enter the class intervals in the first column, then we enter the FIs in the second column. Here the maximum frequency is 28, and hence the corresponding modal class will be 40 to 50. Based on the modal class, let us find F0, F1, F2, H and L. We substitute these values in the mode formula and we get the solution. Here we can see that the modal class is 40 to 50 and L is equal to 40, and F0 will be the frequency preceding the modal class, so it is 12, and F1 will be the frequency of the modal class, it's 28, and F2 will be the frequency of the succeeding the modal class, it's 20, and we substitute all these things in the formula, and when we simplify we will get the mode value as 40.667. So this brings us to the end of part 2. Thank you all for the kind attention. I hope this session helped you understand median, quartiles and mode in a simple and practical way. Thank you once again.